Great. Hi, everyone. Oh, let me switch to duplicate.
Can you record your meeting?
I
Record the meeting, but have the
yeah. Great. Switch. Okay. Hi, everyone. Welcome to Hyperloop's first workshop of the semester. This is going to be a Python workshop hosted by me. My name's Alex. Nice to meet all of you. So first, we're going to go over what is Python, or like just go over a brief overview. And so Python is a high-level object-oriented programming language created by Guido van Rossum, released in 1991. And it's one of the most popular programming languages, and it's pretty easy to start with. So if you look over here, a couple of more popular languages are like JavaScript, HTML, CSS, SQL, TypeScript, C#, C++, C. So the main reason why we chose Python is because there is a lot less syntax to learn, and coding it is a lot easier, or it's a lot faster to get into coding it, and it's used in a wide variety of applications. So next we'll move on to what Python can do. So Python has a lot of use cases. It can do machine learning, web development, game development, data science, automation or scripting, and pretty much anything else you can think of. So here's a couple of examples of what you can do with Python. This is a library called Pygame, so you can make your own 2D games and even 3D games. You also have Pandas, which is a data set library where you can graph out your data set or like visually see it. You also have OpenCV, which is a machine learning library, which uses computer vision to detect objects after you train them. And then, so we'll actually start moving on to how you actually program now. So first of all, we have where we're going to do most of our work in IEE. And so IDEs are just software that help programmers to code and debug and test out whatever you need to code. So there are a couple of traditional IDEs like Visual Studio Code, Eclipse, JetBeans, JetBeans and PyCharm. And so these are software that you have to install on your computer yourself. So if you look over here, this is my Visual Studio. So I can code in here, and then I can also hit run, and then it'll run my program. Or I can also, if I make an error, it will usually pop up something that has an error like that. And I can customize it to however I want. But for today, we're going to be focusing on or using an online IDE because it's much faster to get set up. It's the same thing or it's very similar to a traditional IDE, except everything is like cloud computed and a lot of the stuff you don't need to set up. So today I'm going to be using online Python. You can also use Replit, and there are a couple of other ones. If you want to find your own, you can look up online Python IDE, and then that should also work. So this is what online Python looks like. It's just online-python.com if you want to go there.
mark the
Let me see. Is that better?
Yeah.
Okay. So the first thing we're going to do is make a basic program called Hello World. Basically, Hello World lets you test out if your IDE is working. So in online Python, you're going to just type out print hello world and then hit run, and then it should, here's the run button, and then right here, it should print out the hello world in your console. So I'll give you guys like 1 or 2 minutes to do that and see if it works. Works? Works? Good. All right, so next we're going to be talking about a bunch of basic different commands. So the first thing we're going to be talking about is printing. So we just used our print to do hello world, but more specifically, printing is a function used to display information to the console. And so you can actually format it to add precision or print numbers. So if you look right here, we're gonna declare a couple of variables and we'll go into that a little bit more later. But if you notice right here, there's F in a bracket or in two brackets, and then the name of the variable. So that's how you print out variables in your code without having to uh, concatenate the string, which I'll talk about later. And then you can also add precision right here. So if you do percent point to F, that basically says it's a float and you want it to have a precision of 0.2 of 2 decimal places. So you can code that up really quickly. All right, so if I run this, it should print out number 1 fruit peach. And then if you notice the floating point or the number, it truncates it and then rounds it up. So it's 3.34 instead of 3.33. And then if you want to test out what happens if you put in just the variable, you can just get rid of the brackets and the F, and then it'll print out the actual variable name itself instead of the variable. So I keep talking about variables, but what variables are like basically you can think of it like a box or like a word that you can put your data or your stuff into. So there are 5 main types of variables. There are integers, strings, characters, floating points, and booleans. So integers are just your normal real numbers, like going from like your negative real numbers to your positive. So like 1, 2, 3, 4, 5, 0, -1, 2, -1, -1, or -1, -2, -3, -4, all that stuff. And then we also have floats, which are numbers with decimal point values. And then we also have characters, which is just a single symbol or like sign or character or letter that you can print out as like text. And then we have a string, which if you put a bunch of chars together and string them along, that's called a string. So it's just a bunch of chars next to each other. And then in other programming languages, you will have to specify the type of variable. So in C++, it's actually int number is equal to 5. But in Python, the computer assumes, or the compiler assumes which data type you're using. So if you do number is equal to 5, that implies it's an integer. However, if you do number equals to quote 5, what do you guys think it'll be? Any guesses? Yeah, it'll be a string of 5 instead of a number. So we're also going to do something about inputs. So basically what inputs are is like a little function that you can make your code more interactive. So if so use the input function, you're going to type in input and then 2 parentheses. And then you can just use it like that, but usually you want to prompt the user with something. So inside, you can put in a parameter. or like basically a string of what you want to tell the person. So in this case, input and then please enter your age. And then when you're using the input function, if you just use it on its own, it'll kind of just save whatever input into like space. So in order to actually use it, you should assign it to a variable. And then so you guys can try this. So you're going to do age is equal to inputs, and then please enter your age, and then print out age. And then let me know when you guys are done with that. I'll give you guys like 2-3 minutes. Got it? All right. So as someone pointed out earlier, the input actually results in a string. But we can also check this a couple of different ways. So you can either use the type function. So if you do type and then you put in your variable, it'll tell you what type. And then you can also try doing an operation on it. So if you do age in 10 years and you add age plus 10 and then try to print that out, you will receive an error. So you guys can try that. I'll code it up real quick. And then when you run it, it's, oh, I need to type in a number. It'll give you this error that says, type error can only concatenate string, not integer to string. And then if I just get rid of the addition, or I need a print type. Print type. If you do that, then it should return the type of class. So it's calling it a string. So right here, that's the same error that popped up when I just did it, just so you can see it a little bit bigger. And Python will actually tell you exactly where your error is on like some IDEs. C++ kind of does it. You need to install special libraries and stuff like that. So to fix this, we're going to do something called typecasting. So it's when we take one variable type and then change it to another. So if you do like int and then you put in your variable name or float and put in your variable name or string, it'll convert it to whatever data type you put it into. So currently it's a string and we want to change it to an integer. So we just do int and then put in age, and then that'll change it into an integer. So if we try that, and then print the type again. It'll go from, well, I need to assign it. So int age, or I'll just do age is equal to age. All right, so it goes from a string to an integer. Do you guys have any questions so far? Or okay. So next thing we're going to talk about is the string variable. So like I said earlier, strings are just a bunch of characters lined up, put into like a list, you can think of it. And Python has a lot of different methods you can manipulate strings. It might be kind of hard to see, but I'll give you guys a link to this in a second. But you can like basically capitalize your string, count how many times something occurs in a string. You can center it. You can put in lowercase. You can check if there's alphabetical characters, ASCII characters, decimal characters, digits, and a little bit more. So we're just gonna go over the basic uh, methods for now, but you guys can try this, or you can also look up Python string reference online and then click the W3 schools link, and then it'll show you basically that same chart I had earlier. I'll just go there real quick. So same chart, except a lot longer. And then try this out and see how it actually prints out it differently. And then you guys can use the other different methods too. So I'll give you guys a couple minutes to work on that. Oops. Huh? What? Yes. Huh? Yeah, there's 5 people.
5 people. Oh.
Yeah. Vi and Maggie. And
Wait. Pull it back up again?
yeah. Got it? All right. All right. So we can also or we'll get back to more on strings a little bit, but you can also use something called operators. So operators is just how you do math or comparisons in Python. So you can just do a normal variable declaration, and then you can print it out, and then you can do sum is equal to sum plus 1, and then that should work. But another way you can do it is actually shorthand it. So if you do sum and then the operator you want to do, and then equal plus equal 1, it'll just do the operation all in one and assign it. And you can also do the same thing to strings. So one thing is when you add 2 strings together, that's called string concatenation. Yeah, it's just a fancy word for just like sticking 2 strings together. And then you can also multiply your strings. So if you do hello times 10, it'll print out hello 10 times. And then so I'll just go over that really quick. Right, and then normally you would do the variable is equal to, and then whatever equation you want to do. So we can do sum plus 1, and then print that. Or if you want to shorthand it, you can do sum plus equals 1, and then print that. So if you notice, it adds each time and still sets it equal. And if I change this to like a 3, it'll add 3 and set it equal. Or if I do times, or I can't really divide it, so this, yeah. And then the other thing we can do is do some string concatenation. So hello plus world, and then print hello space. So another thing you can try to do is add an integer on your string concatenation. So if you try this, you'll actually get an error saying that you can only concatenate strings and not integers to strings. So if you use what we learned before about typecasting, we can actually just typecast this integer into a string, and then it should work fine. Yeah. So here's a bunch of operations you can do. So it's not really important to learn all of these all right now. It's better just to have like a little cheat sheet and then just refer back to it when first learning. But we'll go over some of the harder stuff like slicing and indexing and like the Boolean operator or the comparison operators. But before we move on to that, we're gonna just like quickly go over comments. So what I really should have been doing is commenting out the previous code so we can just like save it. But to do that, you just use a hash mark or three quotation marks or three accent marks. So there's a lot of different ways you can do it. So if you do this normal comment, it's only going to be one line. If you do the three ticks or the three quotations, it'll be multi-line. And the thing about comments is that part of the code will just not run. It's just there for other people to know or for you to see what happens there. So if you notice, it says commenting out the following lines to test the add numbers function independently. That's just telling you what the function or what the program does, and then how to use it, and then what should result usually. You can put basically whatever you want in your comments, but to test out to see how the comments work, I'll just put a comment randomly in here, and I'll put a command like print see if I work. And if I run this, you won't see that print statement ever show up. So if you want from now on, you can just comment out all your code. I'm just gonna keep deleting mine because I don't need it. All right, so we also have the if-else statement. So basically what this does is it allows you to use the conditionals that had before, and then check if something is true or false, and then run it. So if you see right here, this one's kind of a complicated example, but I'll move on to an easier example. But if you notice, there's like little indentations, like little spaces. It's not like all flat. So like right here and right here. Basically, what you have to do is indent your code in order for it to run, or in order for Python to know that that's a part of that if statement. So if you look, let's start at the inner part. So if y is greater than z, then it'll run this command right here, but it won't run this else command because it's not indented in. And then for this if y is not equal to z, it'll try to run both of these. We'll go over in a second why it doesn't work, or why it won't run both of those, but it'll try running this block of code right here. And so basically, if this condition, a basic if statement, so if y is not equal to z, if that condition is true, then it will run the following code. And then, so we also have else if and else statements. So else if is very similar to an if statement, except it won't run if the previous elif or if statement has run above it. So if you and then we have the else statement, which catches all the other conditions. So we can try this example. If you do this, it kind of shows what's the difference between using two if statements and an if and an elif statement and then an if else statement. So if you guys try to run this, what do you guys think will happen in the first set? If if the two if statements, num is greater than 10, num is greater than 7, print. And then the current number is 11. So what do you guys think will print out? Yeah, it should print out both because both the conditions are met. So print out greater than 10 and then greater than 7. For the if else statements, what do you guys think it will print? So now it's checking if the number is greater than 42. Yeah, so it'll print out less than 42. And then the last one, if num is greater than 10, if num is greater than 7. Yeah, it should only print just greater than 10, but go ahead and program it and just make sure that it works. I'll give you guys a couple of minutes to do that. Yeah, if you want to follow along, you can take out your laptop and I'll tell you the buttons. Yeah, what's up?
Question?
Yeah.
What's the benefit of using the else if versus the if else? Like the bottom two, using kind of do the same thing, right?
The else if instead of the if else.
Like they'll just run the first one if that doesn't work, or if that's not the condition's not met, then they'll run the next one.
Yeah, so basically the reason why you would want to use else over else if is if you want to just catch everything. So the main thing in program, or at least with the inputs, you'll see that there's a lot of things that users can input that we don't necessarily expect. And it would be very difficult or like very time consuming to just write an else if statement for like everything they try to type that's wrong. So we want to use else to catch everything else. Or that'd be like an example of that. If you want to follow along, you can go to onlinepython.com or use your own Python IDE. Or you can look up online Python IDE too. All right. So here are all the conditional statements. So they're arithmetic operators, conditional operators, logical operators, assignment operators, bitwise, identity, ternary. So in and not in is not super important for us right now, but we'll go into that a little bit later. we have is and is not. So that's just like the Python has this weird thing where you can just type out the condition, like the less than and greater than signs, or like equal or not equal to signs. I personally don't really like doing that, but you can just write it out. It's easier for beginners to like read out a whole statement if it's like if I is not J or if X is not Y. You can also compare if it's greater than or less than or greater than or equal to or less than or equal to. You can add not, so you can basically like add an inverter to whatever logic it is. So if let's say like number is not 10, then it'll just print whenever it's not 10 or do something whenever it's not 10. You can also use an and or an or, similar ideas. There are a couple more operators, but these are like all the basic ones that you should need to know right now. So there's a small little exercise. You're gonna make a random number generator. I already gave you the like template. You just have to put your if else statements in there. But I'll go over what this actually means. So we have import random, which is in Python, you can import a lot of libraries or like a lot of code that people have already made to like do whatever you want, basically, or whatever they coded it to. So instead of like writing our own random function, we're just gonna use someone else's. We're gonna set our number equal to random.random int. So like that's the number that the person should be guessing. We're gonna set a variable equal to true. So this is a Boolean value. So it can only be true or false. And then while this loop is true, so a while loop will just like continuously run whatever is inside the code. And so while play is equal to true, it'll do whatever code you input in there. And then what you need to do is once they guess the correct number, set play equal to false with a capital F. And then that's pretty much it. So you need to check if it's greater than, and then output a message asking them to guess again and that it's too big of a number. If it's less than, output a message that it's less than, and if it's equal to, just send them a correct message and then set play equal to false. And I'll give you guys a couple of minutes to try to do that.
What's the Python?
Yeah, it's onlinepython.com. So import random dots int. And there are a lot of ways you can try to do this. So don't be alarmed if my example doesn't look the same as yours. And let me know if you guys need help. So I'll give you guys till like 6:45 to do it. Okay, sound good? Yeah. Oh, the prompt? Yeah. Let me just copy it real quick. Oops. All right, you guys have about 1 more minute. All right, so how many of you guys got it to work? Almost, maybe. All right. Well, how I would approach it is first I would make a variable called guess. So let's say enter your guess here. So I make a variable called guess and then give it an input or equal to an input. But if you remember guess, or when you use just input, guess will become a string. So you can actually typecast it in here so that it'll process the input and then change it into a string. But just so for clarity's sake, I'll put it in a new line. So int guess is equal to int and then guess. All right, next we should look for some comparisons. We should check if int guess is either greater than the number, less than the number, or if it's right. So if int guess is greater than num. Oh, I forgot to mention this, but when you're writing your if statement, you need this colon here, and then you can indent it. So print number or guess is too high. And then I'll just copy this real quick. And then say elif int is less than and then too low.
It's too.
Oh, is too. Yeah, and then else will print correct, and then set play is equal to false. And then when you run it, it should work. So I guess like 99, and then -100, and then maybe 4, 3, 2, all right, 2, and then it says it's correct. Are you guys have any questions or any different implementation? Yeah.
So I didn't do the high or low. I just, if it's correct, if user number equals the random number, then I'll say correct and I'll set play equal to false. If not, I just said else, try again.
Yeah, that works too.
But then I did all the numbers like 1 through 10 and it still kept on going, like try again.
Let me take a look at it. Or what was your question?
Oh, no, I think that's what is play?
Oh, play. So basically, it's just a variable that tells us if our loop is either like on or off. And then so you can just say like while it's equal to true, that'll be considered on. So like while on, like do the code, and then we need to turn it off once they get it right. So like play is equal to false. Does that make sense? Yeah. Oh, it's because you call it username instead of I think that's sweet. But let me know if it doesn't. So I'll show you guys a couple other examples. Let's see. So this is Josh's. All right, so I'll just reduce this down. So he does it where if its guess is equal to num, then it prints correct, and then uses guess or checks if it's greater than, and then otherwise that means it's less than. And then, oh, I guess that's the only other example I have. But anyways, all right. So now we'll just go over basically what that while was. So basically, a while loop is just a statement saying like to run that piece of code over and over and over again until you've met some condition. And so usually it's an iterative loop, or it could be forever, but usually people use it as an iterative loop. And the drawback behind using a while loop compared to the loop I'll show you next is you have to define it iterative yourself. So if you look at this, num is equal to 10, and then we'll be using num as our comparison to everything. So while num is greater than 0, we're going to keep checking until num, or we're only going to run the code as long as num is greater than 0, and then print out the number and then subtract 1. If we don't subtract 1, it'll run forever. And I mean, if you need a forever loop, you can just do like the true or false, or like 1 is equal to 1, or like some true statement, and you can do that. But usually you don't want your loops to run forever. Yeah.
Wouldn't that crash the computer?
Not necessarily. It depends. It kind of depends what you're doing. But you guys can try it out and let's see. So if you there are very few cases where you want to do like a forever loop. Some like you can also do something called breaking out of it, where like it'll run a certain amount of times and then you'll like literally leave the loop with the break statement. Normally it's fine if you use a while like a forever loop. It's just you don't necessarily want your program to run all the time, and it also just depends what you're trying to do. If you have a bunch of like Python programs running while true, it'll eventually slow down your computer enough to the point where nothing else will run, and then that's when it'll break your computer. But running itself doesn't necessarily break it. None greater than 0, right? And and then if you run this, it should print out from 10 all the way to 1. And then we can also try doing a forever loop in a couple of different ways. While true, right? We do that, it'll just constantly print forever. Some other true statements are 1 is equal to 1. Oh. 1 is equal to 1. What else?
1.
Oh yeah, you could just do 1. I think you can do 1 is equal to true. It should work. Let's see. Yeah, 1 is equal to true. So basically 1 and true are swappable because true is just a binary thing, and you could do 0 is equal to false. So that'll also work. It's okay. All right. So another thing we have is a data type. So basically a data type just holds a lot of data. A data type is just like another like variable type thing that holds a bunch of other data. So this is a list. It stores multiple items into a single, like you can think of it as a variable. And if you are ever programmed in other languages, you might think of it as an array. It's also like, it's pretty much an array, but like way more powerful. So if you notice right here, we can store integers, strings, floating points, and you can even put lists inside of lists. And then that gets really confusing when you're trying to access a list inside of a list, inside of a list, inside of a list. And they're usually defined by these square brackets, and then you can put whatever you want in them. And the main thing is lists are orderable or ordered. So like if you put something in a spot, it will never change unless you change it yourself. So that 20 will always stay at the index 0 unless I tell it to move somewhere else or if I delete it or something. It's changeable, so I can add, remove, modify, do all that. It can contain duplicates. So if I wanted two 20s in here in different positions, I could do that too. And then it's indexed at 0. So the kind of confusing things for beginners is they don't realize that everything starts when you're counting at 0 instead of counting at 1, because we're usually taught counting like 1 to 10. This counts from 0 to whatever size, -1. So for this, what do you guys think the size of the list is? Like, just imagine this is just one thing. So what's the total size? 4. Yeah. The last element is 3, but since it starts at 0, it's going to be 4 elements. Yeah.
So how do you compare that? It's like, or at the moment you put the data, it automatically knows.
Yeah, it'll just know that it starts at 0. So that we have to change our thinking to say, oh, we're going to start at 0.
Like, because it's different type of data, right?
Oh, yeah, it'll just accept it. Python is kind of weird in that way where it just kind of accepts it and like you can just do whatever.
C wouldn't be able to do that.
Yeah, C, you could not do this in C or C sharp or like almost any other language you can't do this, which is kind of the fun part about Python. You can do a lot of like unique stuff. The other thing about lists is if you like rewind like really far back, I said characters are just like a list, or strings are just a list of characters. This is what I mean. So this string is just like character, like a bunch of these characters. So you can also think of this as a list, but instead of like 20, just 3, like all these values, it would be J in the first index, E or index 0, E in index 1, S in index 2, S again in index 3, and then another index, or A in index 4. Yeah.
So let's say you want the first S of Jessa, how would you call that?
In this list or in, okay, so it's, what you would do is first find out where Jessa is. So you do L of 1 is where Jessa is, and you want the first S. So you would count in that and then put wherever the index is. So it would be L of 1 of 0, or L of 1, 0, L of 1, 2, or L1, 1, and L1, 2. If that makes sense. So, no. So I'll show you real quick. So let me just make it. List is equal to 20, just, I'll just put random stuff here. So we want to access Jessa. So if we do, we're going to print out. So you're going to call list, and then you're going to find out where Jessa is. So Jessa is at 1. And then we want to find S, and we already know that it's this third position, but the third position is the second index. So we're going to put 2 in here. So this is saying, look at the first part of the list. And then since it's 2D, we can look at the second in there. So I'll print out just the S.
That only applies for characters, but not for.
You can do it for lists too. So if we, or, it might work for, I don't think it really works for integers that way because they're not considered a list, but we can try it. Yeah, it won't work because it's not like, it thinks of it as like the binary number instead of like a list of characters together. But you can do it with other lists. So if we make a second list with like 10, 20, or oops. All right, so we have a list inside of a list, so we can do the 0 elements. You want to look at, let's say, dog, and then it'll print out dog. And then we should be able to also print out a specific character from there. So that's a 3D array. And so you can like kind of get really crazy with it and like keep digging deeper and deeper. But for now, you should only think of it max as like 2D. It gets really confusing sometimes. But another thing you can do is just print out the list itself. So if we just print out list, it'll just print it out the entire thing for us. And then if you want to print out the list inside of the list, you can just call the index or whatever is up. So let me try that with list2. And then we'll just print out the list inside of the list. Yeah. Yeah.
Oh, you this is the question? No, you're the question.
Oh, and so if you wanted to access like the 0 and 20, could you like cast it into a string, access that element, and then cast it back to it?
Exactly. Yeah, so there's like really funny things you can do. So for print stir list.
Sorry to make you, I don't want to make you actually do it.
It's okay. Oh, I can't do this in one. let me try it. Num is equal to stir list of 0, and then print int num is 1. 0. Yeah. So yeah, there's a lot of funky stuff you can do. You can also convert it to an ASCII value. So ASCII values for A to Z. So each of these characters have like an associated like number value. So you could also do that where you just like, yeah, there's a lot of crazy funky stuff you can do. All right. So there is something called list methods. So if you look there, the operator that like you can access certain parts of the string. So I have this like super long list here. You don't have to copy that verbatim, but just make a list with multiple things. It's a size of 12, so it would be indexed from 0 to 11. And if you print out certain parts, oops. So if you do just the index like we were doing earlier, it'll just print out whatever index it is. You can do the start of one index to the end of another index. And then you can also do it in reverse, in negative, which is kind of weird. So if you print animals 4, what do you guys think you'll get? 1, 2, 0, 1, 2, 3, 4. Yeah, dragon. And then what about 3 to 9? Oh, the colon? That means it's going from one part, like one index, all the way to the next index. It'll print everything in between. Rabbit. So that's 3, 4, 5, 6, 7, 8, 9. You're close. The weird thing about this, for some reason, is it always goes to the end of -1. So actually only print out till monkey. Yeah. And then if you just leave it blank, it'll start from either like the very beginning or the very end, depending on where you leave it blank. So from blank :4, it'll print out rat, ox, tiger, rabbit, dragon. And then if you do from negative, since it's -5 to -1, and it's the end is -1 of where it's at. It's kind of hard to explain, but it'll actually, instead of starting at the very end, it'll start at dog. So I'll do dog, rooster, 1, 2, 3, 4. Dog, rooster, monkey, goats, something like that. All right, we'll cut it out. And then if you don't add anything at the end, then it'll start all the way at the end. So I can do that real quick. Oh, let me try this one.
Just like the initial option.
No, it's okay. Side note, if you're on Windows, you should download this really cool program called Windows Power Toys. It lets you do a bunch of cool stuff, like select text from a screen, or the screen that you're looking at. So that's how I just did that super quick. I think that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What am I missing? Oh, pig. Okay. So just print out some random index for prints from 0 to 4.
You got the wrong standable to be on this software.
Yeah, you're right. Right. And then we'll do this one from 2 to 4, -5 to -1. And okay, so when you run this, it goes dragon, tiger, rabbit, rat, ox, tiger, rabbit, goat, monkey, rooster, dog, goat, monkey, rooster, dog, pig. And because we can access each individual element, we can actually modify it by just changing the value directly. So if we do animal at 11 is equal to cat, and then print animal at 11. So since these are all essentially just variables inside of these lists, we can do anything that we can do with a variable to whatever is inside the list. So if we run this, it'll change it to cat, and then we can also capitalize it. So I guess it's already capitalized. We can put it in lowercase. Maybe I got it wrong. Is it lower? Oh, it's lower. Okay. Yeah. So anything you can do to like a string or an integer or a Boolean value, you can just do in the list. You just have to access it. And then you can also do the same thing in a 2D list. So if it was like even bigger. So you can also do a bunch of other stuff. You can add to the end of a list. That's called appending. You can clear, you can copy, count, extend, blah, blah, blah. If you want to find like a list of what all this is, you just look up Python list methods and then hit the first link. And they'll just tell you all the, like even more things that you can do with lists. So lists are actually like probably the most popular reason why Python is popular, because it's so powerful that you can just like pretty much do whatever you want. And there's actually something called, actually I don't remember what it's called, but you can pretty much put everything in one line. Like I was trying to do it earlier with the 20, like printing out the 0 from the 20. You can do everything in one line. It just gets really, really confusing and like it's not very readable. So I wouldn't recommend it. But if you really wanted to, you can just slap it all of it into like one line statement. Asking a programmer what programming language is best is kind of a Like it's like a religious topic. Like yeah, I mean, all programming languages have their own unique, what is it, like pros and cons. Like Python is very good all around. If you want to do a bunch of different things, I would recommend Python. If you want to do embedded applications, I would say C or C++. Or if you want to do like efficiency stuff, C++. If you want to do web development, JavaScript is really good. If you want to do math stuff, MATLAB.
No, I was gonna do like circuits stuff. Like the circuits stuff.
Circuits.
Uh-huh.
Python, Arduino. It does also kind of depend what circuits you have already.
Like signals.
Signal is definitely MATLAB. You can do it all in Python too. People have made libraries for it. It just kind of depends how much effort you're putting into learning. I think MATLAB is just easier overall because like it just copies the math typing into MATLAB. But Python, you have to learn about all these different libraries and stuff. Yeah. So the other thing we have is for loops. So we can actually iterate through, or it's like a while loop, but you put your iterations in beforehand. So all in one line. So this saves a lot of space and it makes your code a lot more readable. But the more powerful thing is you can iterate through lists. In every other language, you can't really do this. You have to index the list and then you can iterate through it. But this, you can directly access the element and then use that. So if you look right here, it says, oh, one more question. So right here, it says for animals and animals, what it'll do is it'll go through each part of the list and assign it, set animal equals to whatever is in that list. So for the first run through, it'll set animal equal to rat, and then process the code, and then set animal to ox, and then process the code. And then you can try this right now. And like the while loop, it does need to be indented. All right, so I printed everything out in the list like that. And it even concatenated it or let me concatenate it in the string. If you were doing this in C++, you'd have to like reassemble the string back together or like access each individual array element. And it's just a lot longer, a lot clunkier. This is way more simple. And then if you notice, it also has the operation in. This was what I was talking about earlier when we would go more in depth into in. So it'll check if something is inside the list.
So you don't have to declare that variable animal, it declares it automatically.
Yeah, it just automatically declares it. Yeah, so if I also do if cat not in animal or in animals, I'll put this outside before you. And try to print, and then I'll print out need to put in cat. Since cat is not in animals, it'll just run that. I didn't put it in quotes. It'll run it like that. So it'll say need to put in cat. And since strings are like lists, you can also do if cat not in, let's say this string has the word cat. It'll work the same way. And it'll look inside the string to, oh, if it's in, it'll do the same thing and look inside the string itself. So it kind of iterates through the string, and you can use this to find words inside other words or substrings. All right, the last thing we're gonna kind of go over are functions. So functions are blocks of code that only run when it's called, and they have four main components: a definition, a name, a parameter, otherwise known as an input, a code, or the code itself. So it's like the function or the output, or the function and the output. And that also must be indented. So if you look right here, we have DEF, that's how you define it. The function name, and then parameter, and then insert your code there. And it'll run whatever's inside that.
So,
If, yeah.
I think also has with C++, those things are very difficult classes.
Technically you can do it. I don't really use it for that, but yeah, you can do it if you wanted to. But yeah, it kind of automatically decides what's in C++ or Java, because those are object-oriented languages. You have to physically define what's public, what's private, what's like whatever, like so what variables can be used where. You can do the same thing in Python, but Python usually just does it for you. So if you look at our code right here, everything is global, or at least local to the script. And then I'll show you once we make a function, it'll be internal or extra. Yeah, I'll show you in a second. But another thing is, I kept saying function earlier before. So like the print function, the input function, these are all, if you remember, there's like something that you can usually put inside the parentheses, and then that's like the input of the parameter. So these are all basically built the same way I'm going to show you in a second. But someone else just made it for us. So calling functions is similar to defining them. So we have like this function right here, test function. We have a bunch of parameters, a number, an artist, a song, and then we're going to use our print formatting just to print it out. And then so if we do that, it'll just print out the order we put it into. So if you notice, I put one and then the name of the song, Sour Grapes, and then the artist, the Seraphim. It'll actually print out num : Sour Grapes by La Seraphim. But the order kind of matters. Oh, wait. I meant num La Seraphim by Sour Grapes, which doesn't make sense. So whatever order you put it in, it matters. But you can kind of skirt this by just physically defining like what the variable is equal to. So artist is equal to La Seraphim, song is equal to Sour Grapes, and num is equal to 1. So I'll do this. The other thing with functions is if you're returning a value, which I'll do in a second, you have to assign the function to some variable to actually access whatever you're looking at. So we run this. No. Oh, that's it. Oh, not that one. So if you look at the top, that's the wrong output, and at the bottom, that's the right input or output. And let's say we do a return. So this is the output portion. If we return, let's just change this function to odd. So we do X and Y, and then we do sum is equal to X plus Y, and then we want to get the value of sum back. We would use the return statement, and then we could do odd 10 plus 20. But if we run this, since it's not stored anywhere, it'll still run, but it just won't store it anywhere. So if we store it in a variable or print it out, then it'll work. new sum equal to add 10 and 20, and then print new sum. So I'll print out 30. And the kind of weird thing about Python is since it kind of defines everything globally unless you explicitly state it, you can do something like value is equal to 20. And then if you see it right here, it says like it's local, but I can actually use value inside the function because I declared it beforehand, even though it technically shouldn't work if you're thinking in like C++ or C#. So I can just return value instead, and then it'll print out 20.
For this network, you don't need to like the other languages that you will have a like headers and all of that stuff. So they would be down.
Yeah, no, it'll just run like this. So if I just take this program right here and then go into my VS Code and then make a new file, test.py, and then paste that exact same thing. Oh, that's so loud. Oops.
Know what I mean? You're like that's and you could include.
Yeah. You don't need any of that. So if you do this, and then I'll open up my terminal, and then do / or Python /test.py. It'll just run the same way. Yeah. So it doesn't really matter as long as your IDE is set up properly. It'll just run. And you don't even really need much to do this. You just need to install Python and then install some IDE, and then it will just work. Even for text files, if I Shift Alt R, I should just be able to run this. Oh, it ran so fast that you wouldn't be able to see it. So, true. And save. So if I run this, it'll just open up my Python, like some console, and then just run the Python script, and it'll just do it from here. So even if you don't have an IDE, you could actually just code this in a text editor or like a notepad, and then it'll still work the same. As long as you have Python installed and name it .py, something.py. All right, so your next little task is to make a Madlib function. So it just like takes in a bunch of like name, adjective, noun, verb, and then just outputs a Madlib story. It doesn't have to be this story. It can be like kind of whatever you want. Yeah, so I'll give you guys like 10, 15 minutes to do that. I see. Oh, yeah. Oh, yeah, because if you just try to pass S, it'll, I think it'll do it. Oh, do an error? Yeah. Then, yeah. Yeah. You should be able to typecast it into a ASCII character. I thought I think C++, it will typecast it to ASCII. Yeah.
Once you left, you left.
Between 1 and a million. 7,943.
Yeah, thank you very much.
Where was it? 7,943.
Love.
51234.
Even lower.
51234.
I don't know.
51,234.
It's still too low.
600,079.
Wow.
Really? 2, 3, 4, 7, 8. Yeah, 2, 3, 4, 7, 8. 2, 3, 4, 7, 8. Oh, 7, 8, 2. 300,000. 400. 500. 4, 2, 6, 3, 1, 1. Or same thing, but out of 10,000. No. Can I see what you got?
Right. You're really close. Let's see. Um, So first, basically we want the inputs to be like, or you're asking like what the object is? Okay, so what we can do is, but you can say out and then
Yes.
like,
Sorry.
So you have like something like input is, or user input is equal to input. What is your, something like that, right? And then you have your other stuff. So what you can do is put, make a like a function definition and then call it like mad libs. And then since we're not using any parameters, you can just leave that blank. And then we can set, actually, we'll just change this into adjective. ADJ. Okay. And then we can put sentence right here. My day was like, and then like whatever you want to put in there. Okay. And then what we can do is we can concatenate the sentence. So we can add them together. So we can do sentence, or so new sentence is equal to sentence plus your adjective. And then we can return new sentence. And then when we call it, we can do madlibs story is equal to madlibs. And then when we run it, good. Oops, I didn't print it. Prints madlibs story. Good, and then I'll input it there. The other thing you can do is, I'll just call it 2. Oops, madlibs 2. And then we'll do an input of a noun and adjective, or a noun and a verb. So let's say blank went to the market and did blank or something. So since we're passing in the values that we want in the parameters, so they're going to put in a noun, some noun and some verb into the function name, then we're going to use that. So we can do, and since we're adding it to the beginning of the sentence and the end of the sentence, it kind of makes it easy for us. So what you can do is the new sentence is equal to, and then noun plus sentence. I'll just put sentence for now, and then verb. And what we want to do is we want to get rid of like the placeholders we put in our string and just like leave it blank with a space, because it won't add the space in, most users don't type in the space. So then we do madlibs 2, and then we run that. Oh, we need to put something in here. So let's see, cat and 8, something like that. Oh, I didn't return anything. Turn. So cat went to the market or market and ate. So you can kind of change it however you want and just like add more or like make it more specific, add user validation. This is the other one I made. So like this one uses the printf. So instead of like making it all one like variable, you could also just use printf and then like just place in where your adjectives and verbs go instead of kind of doing this, which is a more, I guess, naive way of doing it, where like you kind of just have to like constantly think about where you're putting things and you can't, or it's kind of hard to put it in the middle. You have to like split the string and then you put it back together. All right. So running this. I wasn't right, but it's not live. Is it Alex? Any adjective? Huh? Okay, smarts. A noun. And then a verb. Tutor. I don't even remember what the actual sentence is. So once upon a time, there was a smart Alex who loved to tutor all day long until one day they found a gender. I mean that's my verb. Right. So there's one final topic. So this one's make a random restaurant generator. So this does use all the concepts that we learned. So the program should randomly generate a restaurant name based on a given theme, a menu based on a given cuisine, or an optionally generate a customer review rating based on a rating. This is actually a lot harder than I think you guys are ready for, but I'll just show it to you guys anyways and kind of explain along the way. So my hints were you need to import the random library, have 2 to 3 functions, generate restaurant name and some input, generate menu item and some input, generate customer review and inputs, and then you should have lists for themes, cuisines, adjective, noun, verbs, and sentiment phrases, and then check the user inputs using conditionals and use operators to manipulate the strings. So the way you should go about it, I don't always go about it this way, but whenever you're given a coding task or something like that, you should always write it out, say it out, like plan it out, use pseudocode. And pseudocode is just like code written in plain English. Like I want to take in the user's input, then add some number, then return it. Like that would be pseudocode. And so for this one, I would say I would first break it down into each individual function, like let's say generate restaurant name. So to do this, I should have a list of like themes, like let's say an Italian restaurant, a Chinese restaurant, Japanese, something like that. And then I would just have some random list of names like that, like are very generic for like an Italian restaurant, a Chinese restaurant, whatever. And then those can be like the themes can be one list, and then the like each restaurant name for each type of cuisine or like each theme can have its own list. So like Italian restaurant names, Chinese restaurant names, Japanese restaurant names, something like that. And then I would use an if statement to check if the theme is in the theme list, like some user inputted theme is in the theme list, and then randomly pick the appropriate, like find the list and then just randomly pick one of the names. And then that's how I would go about it. And then you can add a bunch of other stuff. So this is what I ended up doing. It got really long. But we can just focus on this one. So right here we have a theme list, and then we have themes, or I should call this restaurant names, but I'll explain why I did themes in a little bit. But if you notice, I do a 2D list. So it's a list of like Italian, like all of it isn't all in one. You can do this like separately. I just do it all in one just to make it easier on myself. If you use a 2D list, it's a lot easier. So looking at the restaurant name, there's like one part of the name, a second part of the name, and then some theme that you input. Yeah. Actually, I don't need this. Oh, okay. So basically, the reason why I define this here is because I'm going to use it later. So if you have any variables that you want to use later, you should define them all at the beginning. So at the beginning of my function, I define all the variables I'm going to use. And then I'm going to check if the theme is in the theme list. And if it is, it's just going to get the index of it. So I just made a variable called index is equal to theme list.index.theme. So like, let's say I type in like Chinese, it'll just find the index automatically for me. So I'll go 1, 2, or 0, 1, 2, and then return the number 2. And then that's only if whatever theme is typed in is inside the theme list. Otherwise, it will go into the else statement, and we'll go over that in a second. If that's true, then the first part of the name is just gonna be a random choice from the themes. So like this. And then the reason why I did it based on index is because I already know the order of it. So like I know this first row is always going to be, I think I made Italian food. And then this one is Mexican food. And then this one's Chinese food. So I already know that and it's the same as this theme list. Like they're both in the same order. So if I access 2 here and I access the second list here, or the third list, or if I access the third item here and I access the third list in here, that's going to be all Chinese restaurant names. And then we'll just skip the else for now. And then after that, the name part 2, we'll just add some random adjective. And then so I just have a list of adjectives. So you just put that at the end. And then if it's not in the theme list, I'll just ask the user over and over again until they put whatever theme is in the theme list. Just keep asking them repeatedly to input the same theme, an actual theme, and I'll print out the theme list so they know what to input. And then I just do the same thing where I check the index and then just assign it to the same part. So it's pretty much the same as the if statement. I just kind of did it a little wonky. And then it'll just return the name part 1 plus a space plus name part 2. And then the generate restaurant menu theme is very similar, except this one, I return a list of items. So I'll look for the theme if it's in the theme list. And then if it's not there, or this time I do it a lot smarter, where I ask for the theme first and then check it there before I go into the input out like this one I have to check it through 2 times. I have to check the if statement and then in the while loop. This one I only check it once because I put the while loop outside of the if statement. And so it'll check if the theme is in the list, and once the theme is in the list, it'll find the index of it. And then basically what this does is it just randomly selects from, it's the same idea where I have just a bunch of menus that are in the same order. So it'll just randomly select one of those and then remove it from that list, and then select another one and then remove it, and then select another one and then remove it. and then print out the resulting list. The review is kind of more of what I expected you guys to do if we have time, if we had time. So you have the themes, the theme list, and then just like a 1-star rating, 2-star rating, 3-star rating, 4-star rating, and 5-star rating. And so it kind of just like uses a bunch of if else statements and then just like adds everything together. So we only really need to look at one of these. So this raw part is the same as all the other ones. It just keeps checking the user to input like a number between 1 and 5. That's it. And then if we look at the if statement, so it's going to check if the rating is 1. If the rating is 1, then it'll choose a random like adjective from the 1-star list and then remove it, and then randomly choose another one from the 1-star list and then remove it. And then after all that, the review will be equal to the restaurant name plus the theme plus the rating and then the rating. But really, you can just get rid of like this part. Yeah, so this is pretty much what you guys we're doing close to having like that's like quaint spot with like some random adjective, food, and some other random adjective, service, and then like the star rating. And then to use it, you just call all of them and then input your certain parameters, and that's pretty much it. Do you guys have any questions? I know I kind of went through that fast and it's kind of long and confusing. I can go back to any parts. Good? All right, I'm just gonna stop sharing and stop recording then.